So let's chat about where we're going then. So that's our homework for today, right? 21 to 26. Let's clear up any confusions, because who knows, maybe I'm confused. So this is chapter 7 for CC2. You might have overheard me talking to somebody about CC3 or a different book. But yeah, we have a lot of sections in chapter 7. 7.1.1 we did before break. That was our dirt lesson, where distance equals rate times time. We watched the video with the water bottle, right? And we were talking about the water leak. Sad story. Over break, and I should have taken a picture of this so I could show you guys. I showed back up at my house one morning. I was out doing some errands, and there's a crew across the street. Another one of those blue signs posted, and they are cutting down a tree. And it wasn't that big of a tree, but it made me sad because they cut down a tree, and that's a tree. Another water line right across the street from my house had broken, and it's been leaking for probably about a week now. And it literally just water, just all over the sidewalk, like it's constantly leaking. So if we remember just to bring it back in our brains, that formula that we used was D equals R times T, right? If you want to jot that down just to bring your brain back to where we were before break, that distance equals rate times time. Remember, we talked about distance doesn't actually have to mean inches or miles. It could be how many gallons. Could be our distance, quote unquote. Could be how many cookies. Distance doesn't actually have to be a rigid distance. So that's where we take it today with our lesson about scaling quantities. Yes?
I was wondering, when we put the header, it's the small word.
It's scaling quantities, yeah. You could really just call it scaling. But we're still going to be using this formula, so that's why I wanted to bring that back up in our brain. Anyone watching basketball over the weekend?
My grandpa was.
What do you mean, what? Are there no basketball fans in here? Now, I'm not really a basketball fan, but what month is it?
March Madness.
March. It's March Madness, right? So the collegiate basketball tournaments, so colleges, right? The biggest culminating event for them is March Madness, and it is about to happen right now. The brackets were all just determined last night. So there's a ton of math that goes into that, including how the teams are seeded. So if somebody talks about the seed of a team, that means their rank. So you could have a seed from 1 seed all the way down to 16 seed. Now, why am I talking about basketball?
I don't know.
Because there's math in everything. And last night, Dave, my buddy Dave, who is a big basketball fan, said something that I found pretty interesting. He said, Nan, that player's on fire. He has sunk 21 out of 22 of his free throws. When you go to the line and you get a free shot at basket. That is pretty good. But then they talked about another player that came up to the line next, and they said, oh, he's been shooting 61%. So if we think about, his success is 61% of however many free throw shots he makes. Now, obviously, we can't be perfect, but this is exactly that distance equals rate times time formula. The amount of free throws he will make is 61% times what would go here. And our time spot, because that's our rate, right? The distance, how many he's going to make. Our rate is 61%.
Time.
Yeah, but what is time? Times, we could actually call it here, times he does what? Yeah. Times he attempts. Times he makes. So if he shoots 20 free throws, we'll say he'll make approximately 12. So what we're doing today is called scaling quantities, but it's relating one value to another with some rate, some fraction or decimal. So if I tell you I make half of my free throws, and in the game I shoot 10, how many do I make? 5, right? That's what we're doing today. So if I tell you I bought a dozen cookies, and I'm going to give Casey a fourth of them. How many does Casey get? Ooh, 3, be careful. A fourth of 12 is 3. Now, this also flips around. A third of 12 is 4. Yeah, so be careful with those two fractions. All right, we're ready to dive in. I just wanted to give us a soft, slow start back at it. So, Diana. Be quiet. Class has started.
Mr. Hudson,
Yes.
you said that there's math and everything. I have a great question.
Okay.
Is there math in Casey's rainbow sweater?
Yeah.
How?
It's tie-dye.
How many granules of dye went into how much water determined the density of his color that came out. How it was folded is the geometric application that ends up creating the tie-dye pattern, the different ways that you could put the tie, like the dye on. I also used to do summer camp where we tie-dyed shirts every week. And while we were tie-dyeing, I just talked. I fill open time with talking. So I would talk to the kids and be like, "This is geometry," and they're like 7. Okay, now I'm genuinely kind of nervous. For the first time ever, my wife and I are riding Pelotonia this year, and if you don't know what Pelotonia is, it is a huge fundraiser for cancer research. My niece, Abigail, and I think we talked about this at the beginning of the year. My niece, Abigail, had leukemia from the time that she was 2 to the time that she was like 8. And my mom had breast cancer. So cancer's pretty close. Like, you know, it impacts a lot of people. But we are actually doing Pelotonia. Like, I'm not making this stuff up. So Dana is training for a bicycle race, right? Just like I'm gonna, as soon as weather breaks, I gotta train for this bicycle race that's in August. And I'll be like, you know, trying to get donations. And what I'm nervous about is trying to get donations. I have to raise like $1,500 for cancer research, which just means I got to go ask a lot of people. But so Dana's training for a bike race that is gonna be Dana can ride at 25 miles per hour. 25 miles. So let's go ahead and put down 716 on your paper. 716. Make sure we know what problem we're working on. And what we know right now is 25 miles per hour. So go ahead and jot that down because they told us that. And we can abbreviate miles per hour in mph. That's what we like to do. Now one day, he'd been riding for 3/5 of an hour. And then he had to stop to fix a flat tire, which happens. Sorry, it's heating up in here. When you guys come into the classroom, it gets warm. So if we set this up with a line model, we know that he could ride 25 miles in 1 hour. Go ahead and set that up. Just don't break it apart. Just one big line. 25 and 1. So start, stop, 25 miles. We abbreviate miles MI, not just M. Too many M words.
M word.
And hours, HR, not just H. Too many H words. So if we're talking about 3/5 of the total time he was going to ride, right? 25 miles per hour. If he rode for an hour, he'd go 25. But he didn't. He only rode for 3/5. So they show us we can break apart our line model, which some of us had issues with in like that test, like last chapter or whenever it was. So please, like, be with us. Let's break up our line model into 5 sections. True confession, I'm bad at this because it's an odd number. So you're going to draw 4 lines to make 5 sections, like 4 breaks. So now I have section 1, section 2, section 3, section 4, section 5. So they're not quite exactly the same size. So go ahead and do that on your paper. You'll probably... they should be the same size because each of them is a 5th. Right? So as opposed to one section is like a half and another one's a 5th, then they would be different sizes. But that's why these are all supposed to be the same size. Now, artistically, I'm not that skilled, so yeah. Questions on what we've done so far? So then take 15 seconds, turn to your partner and tell them how far Dana had actually ridden before she had to stop with a flat tire. Or maybe he. I don't know. Dana's kind of a neutral name.
I have an aunt named Dana.
Yeah, right? It could go either way. How far had Dana ridden? How far had Dana ridden? Ooh, I should get out cards. Back from break. Riley Sesta, or generic student number 7. How? What? She always calls me Mr. Teacher, so I started calling her generic student number 7. If she can't remember 6 teacher names, it's the joke that Riley says Mr. Teacher.
No, she just said, what was that laugh?
Oh, break was too long.
It really was.
So Riley, how did you get to 15?
Okay, so like what you did before was the 12 and like 3 and I did that, but like it's since it's 3 over 5, then I did 25 and 3.
So you did the multiplication? Absolutely. So that's one way that we can do this. So Riley said if we want distance equals rate times time, the rate was 25, which we could put over 1. The time was 3/5. She did that multiplication and got 15. I 100% agree. But another way we could do this that kind of makes sense with our picture, how did we break up our line into, how big are these sections? Fifths. If I look just right here, that's 1/5. Right? Can I break 25 into fifths?
Yes.
What would each fifth be worth? 5. So 5, another 5, another 5, we get 15. Any questions?
Wow.
Ada.
Okay, I have a question.
Yes.
Okay, at the end of class, can we watch a video?
No. Not if
How
you're...
would you look at that?
Okay, so maybe tomorrow, but I'm not just going to blindly put a video on that you just asked me randomly on YouTube.
Okay.
Now, you are going to watch a video when you go to Language Arts, like a movie, so at least you get that. It's the Sound of Thunder. Sound of Thunder. If you don't know what that is, you haven't been awake as you've been at school before. You read the short story, you listened to Ray Bradbury read the short story. Hey, Aiden, take your attitude and fix it. Alright, next question. Moving on. So, guys, that was scaling a quantity. We just scaled down his 25 miles per hour. We scaled it to 3/5 of what it actually was, which 3/5 of it was then 15 miles. So if we talk about how much of the race does he have left, he's got 10 miles left, right? So if we try to apply that to geometry, and you don't really have to write anything for this one, if you are told that a new shape or a new something is 3/5 of an original, we do the same thing. You just take your 3/5 and you multiply it by 25. And like Riley told us, it's easiest if we make them both fractions, because the 25 and the 5 work well together. So then, if we move on to 18, actually go ahead and number this, because we're going to write this out and look at some labels and what works to change these labels.
7.
Yeah, 7-18, please. The first, well, 17 was just showing you how the geometry works. We didn't skip it. If you skipped it, you weren't paying attention. This, right here, how the geometry works. We just did that math.
Yeah.
17 was just saying this is how it would work with geometry. So, what we technically have here is 25 miles per hour. So what we really have is 25 miles over 1 hour. Go ahead and write that if you would, please. Then they tell us the time, 3/5 hours. Right, now we could talk about that in minutes, but we don't want minutes because we're working in hours. So that 3/5 is how far they've gone, right? So if we're doing distance, rate, time, we need to multiply because my distance will equal, this is my rate and my time. So 3/5, but since that's 3/5 hours, the label either goes out here beside it, but for us, we don't really like that since we want the label to be on top or bottom. So it actually goes in the numerator. Because that belongs to that value. And if we could also write that as 0.6. And again, the label goes like 0.6. So if I try to put that into a fraction, that's why the label goes in the top. Because this 3/5 of an hour, 3/5 of an hour, because that's 0.6, this is equal to 3/5. But my label would still belong up here. Does that make sense why when we just have, like, if you have 12 pizzas and you try to make it a fraction, it'd be 12 pizzas over 1. Right? There'd be no label down here. Question. I see some confused faces. I can't tell if you're just like processing or if we're confused. So if they tell you just a single thing, hours or miles, that goes in the top. But if they tell you miles per hour, we got to split them. Wait, what? Wait, what? Yeah, you said wait. Wait, what?
Wait, so you were just explaining that to us, not the problem?
This is the problem.
But you're just
So,
told us
we're understanding why the labels do what they do. So the answer we got, what'd you say it was, Riley? 15 what? 15 miles, because if there's a label in the numerator and a label in the denominator, they reduce each other out. So please circle the hours in the numerator and denominator, and don't like cross them out super dark, but just put a slash through them to show you that if we can put a label in top and in bottom, that label will cancel. This, and I'm not sure if this was made up or not. I believe people, my chemistry teacher in high school told us, she might have been lying, but she said that this is stoichiometry. And what stoichiometry, quote unquote, because I need to look it up and see if it's real, is the conversion of units. So if you like talk about money, you know how to convert from dollars to pennies, right? Or dollars to nickels, or like you know how to convert that. We do that with everything. Now I will apologize to you from all of everyone who's ever made decisions. The fact that we are in America is going to make your life tougher.
great.
How many feet are in a yard? 3. How many feet?
I'm sorry, I'm thinking it's just
How many feet are in, or how many inches are in a foot? 12. How many inches are in a yard? 36. How many feet are in a mile?
A lot.
no, it's 2007.
Write this down. Nope. Write this down. Because we're going to start talking about distances. 1 mile.
I don't think so.
I know what
A mile is 5 tomatoes.
Wait,
Guys, I could never remember this until somebody told me that. A mile is 5 tomatoes. A mile is 5 tomatoes. 2 tomatoes. 280. A mile is 5 tomatoes. It is 5,280 feet. If you were in Europe and somebody told you to drive a kilometer, who knows what kilo means? 1,000. So in a kilometer, there's 1,000. We're stupid.
Yeah.
We chose, if I haven't gone off on a rant about this, we as America said we'll go to the metric system. We will use the metric system. We signed a treaty. Literally, you can look it up. It's called the Treaty of the Meter. And then we backed out and we said, actually, we don't want to change our signs and what we're used to, and we're just going to stick with the American standard system. And the rest of the world went to metric. This is something you need to memorize. So if you didn't write it down right now, please. 5,280 feet. You'll eventually be asked to convert something. Now, you have this on the standardized tests, like they give it to you, but you're an American, you should know how many feet are in a mile. I apologize that it's gross, but that's what it is. 5,280. 5 tomatoes. Some of us, on our homework, have been weak.
I like those.
Could we talk about 3/5? Now, I don't really care about the picture, but do realize there are 2 main ways that we can picture these things. We could have 5 of something, and 3 of them could have a unique characteristic, or we could have something broken up into fifths, and 3 of those 5 sections. Here's what I care about, that you can quickly and efficiently convert between the fraction of 3/5, and sometimes it takes thinking about another fraction. 3/5 is 6/10, right? We can double the top and double the bottom. So what is this as a decimal? Well, we should know now. 0.6. And then as a percent, 60%. This is where we keep tripping up. This is why I'm very much trying to go slow today. Some of you can probably feel that if you want to move faster. 6% would be 600ths. Okay, guys, we've been saying all your percent out of 100. This isn't 600ths, it's 6/10. If you want to make it hundredths, well, just do it. But then it's 60. Okay, so be careful with these. This will be on your test, and really just being able to apply those to make your problems easier. Sometimes the decimal's not the easiest. With our 3/5 of 25, would you rather multiply 0.6 by 25 or use the fraction form? I would rather use the fraction form. It's way easier. So, please, as we go through our practices, do practice converting those. I don't really care much about your picture, but I care about the points of the triangle. And you can just draw a triangle on your paper and put the values at the points. Okay? Cool. Please. Thank you. All right. Let's solve part C here. What does of tell us to do? Multiply. So I want you and your partner to determine what's the easiest way to solve those 3 problems. 90% of 25, 8% of 75, and 25% of 144. You may use the percents as they're given to you. I mean, you have to have a calculator then. You can use the decimal form of the percents given, or you can use the fraction form of the percents given. I'm going to give you probably 4 minutes to do this, and I'm going to random card to ask you what you thought was easiest. Don't just say, well, I had a calculator, so I would, think about it. What's going to make this easy? What works well together? Dive in. Can't ask me unless you've already asked your partner.
Oh, yeah.
Ooh, I like what I'm hearing from Casey's group. Yeah. What's up? So you thought I needed it? Mr. Shurg thinks I look hungry, apparently. Is this snack anybody's? He's very nice and he brought it back to you. Nora, you owe some thanks to Mr. Shurg. Thank you, Mr. Shurg.
Yes, I do.
Can I do math with the percent form?
Yeah.
Not unless I have a calculator that has the percent button, right?
Yeah.
So I kind of normally throw this option away. Like, it's not the easiest, at least if we were trying to do the math. You got an opinion on the easiest, Ethan?
Oh no, I was just saying you can do percent with that.
What do you mean?
Well, for round numbers of 10, you just find 10% of the number. That's a big number.
So he said for round numbers of 10, so you mean 10% of this?
Yeah.
So what's 10% of 25? 2.5. So if we find 10%, we can kind of use percent form. What do you do from there? Yeah, we can multiply by 9. So again, break it up. 9 times 2, 9 times a half. Sorry, this would totally work. What answer did you get?
22.5.
Now I heard someone else say 90 hundredths, and then I heard somebody say 9 tenths. So we have both fraction forms there. Ava?
Wait, couldn't you just do 5,280? Oh, what? Right?
We're not trying to figure out feet. That would be if we were trying to get feet as an answer. Right, we could involve that, but if we wanted feet for the answer. So, remember, so you're right now both making me feel like I can't let you work together in a group because I don't think math is happening. I think we're having a good old time. But the fact that you just asked that question means you didn't read the problem to know what you were doing. We are just trying to scale these quantities. Me giving you that 5,280 feet was just like information that I want you to have.
I understand that now. I'm just thinking something.
Of always tells us multiply, right? So even though it's part of something, 90% of won't be the whole thing. This makes sense that we have an answer less than the total, right? If you got an answer bigger than 25, that should set off an alarm in your head. That wouldn't make sense. Yeah.
Those little things, all the lights should lit up.
Yeah, I know. My smart board's kind of broken. It cycles every now and then and has to like reset itself. Another way that we could do this is 9 tenths of 25 over 1, right? Because if I try to make 25 a fraction, it becomes 25 over 1. This still leaves me multiplying 9 and 25, which I'd probably have to break up if I was you, or if I was me. I mean, if I was doing this. I would do the 9 times the 20, and then the 9 times the 5, and then we'll still have to divide by 10. So this, I'm guessing, probably would get us 225, and then we divide it by 10. We get our answer here. Now the other way, grab your decimal, use your calculator. 0.9 times 25. Eva?
What I do is I just take 90%, put it into multiply.
Absolutely. Yeah, that was the last thing I said, is if you got a calculator, just use a calculator. All right, 8% of 75. Nora, how'd you do this? The decimal? So what is the decimal of this? 0.08. Yeah, be careful of that. Times your 75. And what do we get? 6 or 16?
16.
16?
16.
What?
16.
So this just doesn't make sense to me because 8%, guys. If you got 60, you're not using the right decimal. Guys, 8%. Write this on your paper. If you got the wrong answer, 8% becomes 8 over 100. Guys, so many of you keep doing this. 8% is not 0.8. It's 0.08. It is 800. Please turn your brain on and give a crap. I'm going to get real straight up in quarter 4 here, because one, we know each other pretty well, and hopefully you believe me at this point that the only reason I work this job is because I care about you guys and I want to make your life better in the long run. But I got to give you some homework to make that happen. The answer keys are in Schoology. As you do your practice, check it. Because I don't care to collect your practice, if I'm being honest. I really wish I didn't have to. If you could all just do it without anybody checking it, I wouldn't ever collect it. I don't care about it. You need to care about it. If you aren't checking your practice work and you keep making mistakes like this, the only person to blame is yourself. I can't fix that. I'm sorry. I've done everything I can. If you can't get yourself to write out the work and I can't fix it for you. You have to make that change.
So, do you look over each practice?
I look at your homework to see that you did it and engage with the math, but honestly, you could copy that from somebody. So that doesn't really tell me anything. It needs to tell you whether or not you understand the math. The practice is for you. It's not for me. Nothing is really for me. The only reason I grade your tests and stuff is to give you feedback so you know if you know what you're doing. You should be doing that for yourself on your homework. At some point, that'll click. And for some of you, it already has. This isn't a game, and I'm not in charge. This is for you. This is you growing and learning. We're just here to help. That's it. Where it's not some game that you're playing by my rules, and no, you're just trying to grow. That's it. I'm still trying to grow. All people should be still trying to grow and get better at things. So from this, we should get 6. I believe you got 60, 60. You're 10 times too much, which is because you used a decimal. That was 10 times too much. That's why it got broken. Now, Casey, I'm going to jump right to you, even though it's not your card. Your group, I was going to say, but you said something really interesting about 25% and how that's easy.
It's just a quarter, which is a fourth, so divide 144 by 4.
The nice familiar percents we can reduce down normally pretty fast in our head. But Casey said, yeah, well, 25%, 2500ths is just a quarter. And in my brain, because I got to make life easy, that to me says cut in half, cut in half. Because dividing that by 4 is not actually that easy. But can I divide this by 2 pretty easy? What's half of 144? Yes, right, break it. 140, well, half of that's 70, and then half of 4, 2. Can I break this up again? Yeah, what's half of 70? 35. What's half of 2? 1. So we get 36 for our answer of just 1/4 of 144. Now that, for what it's worth, is a dozen dozens. This is a number called a gross. Literally, GROSS stands for a dozen dozens. So if you think about something like a gross amount of Twinkies or something yeah, that would be a gross amount. That's a lot. 144, yeah.
Twinkies can last a long time.
They can apparently last forever. Questions on those 3 scaling quantity problems? Because that, guys, is the main part of what we're doing from here out. So please care about your practice to make sure you understand this well. If Josiah wants to leave a 15% tip, which is pretty standard tip amount, on a bill that was $38, we want to leave a tip of, so let's write down tip, and this is $7.19. We want the tip to be 15% of the bill. And normally it's anywhere from 10 to 20. I normally tip 20% if it's good service because I've worked the jobs where you get tipped. And when people don't tip you very much, it makes you upset. upset. I don't know why I was about to say upside down. Turned your world upside down. So 15%, right? 0.15 if we want to put it decimal form. Or we could do 15 over 100. CC pencil's not moving, and I doubt that you worked ahead and did this already. Now, the bill, how much is the bill right now? 38. So she has to pay 38. The tip is extra because you're a good person. And again, America, we've set up some weird things. We just don't pay people enough, so that's why we tip them. If I try to think through easy ways, I could do 10% of this, and then another 5%. So if we take the Ethan method that he told us a few problems ago, 10% just bumps the decimal. So here, 10% is how much? 380. Because guys, realize and take a moment to like hear this. 10% is a tenth. When we do a tenth of something, we grab the decimal and bump it left. If you wanted to do 100, you bump it left 2 times. So we could find 10% that way, and then we could do 5% as just half of this. Now, I'm not telling you this is the easiest way, because this probably for a lot of you are thinking, I wouldn't do this. I would just use my calculator. But if you didn't have a calculator, 10%, 380, if I cut that in half, what's 38 cut in half? Well, 19. So 5% is 1. I can add those together and figure out my tip, or get a calculator, right? We live in a world of calculators, and I will tell you, if we ever end up at dinner together and you try to use a calculator for the tip, I will smack it out of your hand. I do it to my friends all the time. Ethan, what do you get? 5.7. So we're leaving $5.70. Honestly, we'll probably just leave $6 and leave a little bit extra.
Because humans don't like just.
This is why we scale quantities. And actually, I got on a big rant in my afternoon Math 7 class, and then Desi texted me a picture when she was out shopping, and it had like 10% off, 20% off, 30% off, and it had every single pricing done on like a sign, so you didn't have to do any math. But it was all 10%. It's like 10, 20, 30, 40. It's all multiples of 10. It was all just the same amount, like added or subtracted. Because every 10% is the same as every other 10%. Like, it was one of these sort of things, and it just drives me crazy when they do the math that is super easy. But you want to be able to do this when you're out shopping, and especially if you want to get a discount on something and somebody tries to, like, rip you off, you want to be able to do the math in your head. Yeah. Depends. Most people really have kind of been eating out enough, like adults, that they just kind of have tipping worked out in their head, whether they actually do the math or not. So, like, if you want the real, like, response of that, is it all depends on where you're at. If you're at a nicer restaurant, you'll probably tip a bit more because they have, like, really nice service and they're being, like, very, very polite to you and everything. Like, they provide a good service to you. If you're at, like, you know, like Max and Irma's or somewhere where it's a nice restaurant, but it's not like nice. It's just like table service and like, yeah, tip a few bucks. The easiest rule is at a minimum, you should tip 10%, which that's easy because you bump the decimal. So if my bill was 38 and I want to tip the minimum, bump the decimal, tip 3.8. That'd be the minimum that you want to tip. Now, the other flip side of that easy rule, if it was nice service, double that amount. And then you're at 20%, right? So you can get your 10% real easy and then get to your 20%. So Isaiah found a game that was 35% off. We're going to do this real quick. So Isaiah found a game that was 35% off. Go ahead and on your paper real quick, just write 35% off. And the game actually costs $40. Now Isaiah has been having a math class about scaling quantities, and he's like, yeah, we can just do 0.35 times 40, and I'll get my new price.
Oh, but alas, it's not gonna
Don't write that down. Is he going to pay? Forget about tax. We're going to say it's a tax-free shopping day. And they do that twice a year. They do that twice a year. Is Isaiah paying 35%? It's 35% off. Now, we could do this math and then subtract, do the discount. Or how could we change our thinking to make our life easier? If it's 35% off, what percent is on?
75.
Not 75, 65. So be careful. That's not the sale price. If I want to do the sale price, I got to use 65, and this is my percent on. So please just make a note, and then we're done here. You want to think about your percent that is on. As you do your homework, that will shortcut you to the answer. Now, real fast, and you don't have to write this down, but guys, what's 10% of 40? 4. Bump your decimal, right? So then 4 times 6, 24, right? And another half of the 10%, so 28. Yeah, the sale price ends up being $28, and we are done. I gotta get you guys out of here because then we gotta switch you around and start your movie over here. Please pack up your stuff appropriately. I like that.
My disappointment for the math language.
Let's go. Math 7, you got a movie to start.
Run, like the wind.
I would say it's nothing like the book, but then again, it's not supposed to be.
Well, what's happening there? So, get ready for some angry picking boys.
Micah, the sound of thunder is nothing like the book.
Nothing.
I'm gonna get angry.
I hate when they're not like the book.
I hate
I'm sure Terry watched
like
it.
the
It's
book.
not even like
Thanks.
they barely. I'm not. Everyone's missing over. Oh, who was the main character of the book?
How's the movie?
They're animated.
Nothing like the book.